I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of algebra within the Year 11 standard course. We're looking at linear relationships, which comes under MSA2. So in this video, we're going to have a look at the gradient-intercept formula, and that is the equation of a straight line. So you may be familiar with this from previous years in Year 10 or Year 9, but gradient-intercept formula is the equation of the straight line where y equals mx plus c. Now you may see it written as y equals mx plus b. B and c mean the same thing. They both represent the y-intercept, but they're just different letters to represent that. So if I accidentally say b instead of c, I apologize. I'm just used to saying B, and I think saying C is a new syllabus thing. So we have y equals mx plus c, where m is our gradient. So the letter or the number before x is going to be our gradient, and the number or the letter C is going to be the y-intercept. So what is our gradient and what is our intercept? Well, let's have a look. So firstly, our gradient is the slope of the line. And our gradient is can be found by doing rise over run. So that's where if you have a number plane and you have a straight line going through here, and say this is value 4 and this is the value of 2 and this here is 0, 0, you create a triangle with 2 points. So I'm going to choose that point there and that point there. You could choose any point on your straight line. These are the points that I've just marked out, so they're the ones I'm going to use. And you create a triangle. So you create a horizontal base and a vertical height, and then you can ignore the hypotenuse, but that makes up our triangle. And then you do rise. And so our rise is from the bottom of the triangle, so from this point here, which for us is 0, to the top of the triangle. So this would be the rise, from there to there. And we are going from 0 to 4. So our rise is going to have a value of 4 because we're going from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. So that is a value of 4. Then we're going our run. And our run is going to be from this end part of our triangle to this part of the triangle. So that there is going to be our run. And we have a value of 0 here to a value of 2. And so we have 0 to 1, 1 to 2. So we have a value of 2. And so that is going to leave us with a gradient of a half. And so if we were to write that in gradient intercept form, it'd be y equals mx plus b. And we can sub our m as our gradient. So 1/2 x plus b or c, whatever your y-intercept is. So that's how you do your gradient. If for whatever reason your straight line actually went through other points that didn't come from 0, so what I mean by that is if you decide to use the points to find your slope of the line that comes from here to here, and you don't start from 0 because 0 is at this x there. Say this was 100 and this here is 600. Your rise would then be from 100 to 600, not from 0 to 600. So our rise would be from there to there. And so from 100 to 600, that's a rise of 500. So you just have to be mindful of where your start is from the bottom of the height to the top of the height. And the same thing goes for your run. So that's the gradient, it's the slope of the line. And now let's have a look at the intercept. So the intercept is where the line cuts the y-axis. So it could be a x-intercept, but we focus on the y-intercept because the y-intercept is the one in our gradient intercept form. We have y equals mx plus b, or c I should say, actually. And c is our y-intercept. We don't have a place in the formula for an x-intercept. So we just ignore x-intercept and we just focus on the y one. So the y-intercept is where the line cuts the y-axis. Where the line cuts the x-axis would be the x-intercept because it's intercepting that x-axis. But as I said, we only focus on the y-axis. So if this here was a value of 3, then our our y-intercept, which is marked by C, would be 3. So it'd be mx plus 3. Because we have a crossing or an interception of the line at the value of 3. So that's the gradient and the intercept, and the gradient and the intercept make up our gradient intercept formula. There's one other thing to be aware of when we're doing straight lines, and that is if you have a positive or a negative line. So if it is a positive line, it will have a positive x, so it will be y equals x, which is positive, plus c. And if it is a negative line, it'll be y equals m minus x plus c. And there's a times in there. So if our x is negative, then we will have a negative straight line which goes in that direction. And if we have a positive x, it will go in the other direction and be positive. So we'll talk about more about this in the next video. But just remember, if your x is negative, it's going to be a negative line, so it goes in that direction. And if your x is positive, then it'll be a positive line and it will go in the other direction. So the line is kind of angled towards the right, or the line is angled towards the left. So let's have a go now at identifying our gradient and our y-intercept. So the question says, write down the gradient and y-intercept for each of the following equations. So if I write down our gradient intercept formula, we have y equals mx plus c. So if we have a mx, whatever number is next to x is going to be our gradient. I'll put a G there for gradient. And whatever number is hanging on towards the end or by itself is going to be the y-intercept. So if we have a look at the first question, A, we have negative y equals negative 2 plus 5x. So whatever number is hanging on to the x is going to be our gradient. So our gradient is going to equal 5. And whatever is left hanging by itself is going to be the y-intercept. Then if we have a look at question B, whatever is next to the x is going to be our gradient. And we don't have a number here, so we can imagine that there is a 1 there. And because there's a negative associated to it, our gradient is going to be negative 1, which means we remember that if your x is negative, it's going to be in the heading towards the left. And our y-intercept is going to be this thing hanging by itself, which is going to be positive 8. Then we've got our gradient for c, and we have the number associated to the x is our gradient, which is 6. And we don't have a y-intercept here. There's no y-intercept. So our y is going to equal 0, which means it doesn't cross the y-axis, and it will go through the origin 0, 0, which is here. And so because we don't cross the y-axis up here or down below, we just have a y of 0. We don't have a y-intercept. And for D, we have to rearrange this equation so that it's in gradient intercept formula. Because at the moment, this equation is not in gradient intercept form because our y is not by itself. Our y is not the subject of the formula. So let's rearrange it quickly. So y equals negative 3x, y minus negative 3x equals 4. We want to get y by itself, so let's add the 3x to the other side. So then we'll get 4 plus 3x. So now that it's in gradient intercept form, we can see that whatever number is associated to the x, which in this case is 3, is going to be our gradient. And whatever is hanging by itself is going to be left over, which is 4. So as you can tell from these questions, the formula for a straight line is not always written in the gradient intercept form. So if it's not written in the gradient intercept form, you will have to rearrange it so that it is, so you can associate which one is which.